Hello, everyone. Good morning. Dear authors and invited guests, welcome to the technical session at 5F. My name is Siddhi Auti and I'll be your session moderator for today's session. On the behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being held in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held via Zoom meeting today and tomorrow, that is on 5th April and 6th April. I hope you all will enjoy today's interactive session. In this session, in total, we will be having 10 presentations. Each presenter will be given a time span of 10 minutes for the presentation, from which 2 minutes will be kept for question and answering. After 8 minutes, I will be raising a gentle reminder for everyone. Also, there is another request for all the participants to stay connected with us till the closing remarks. If you face any issue or have any query, you can write it to me in the chat box and we'll be taking care of it. Now, just before the session starts, I would like to introduce you all to today's session chair, Dr. Parth Shah. Dr. Parth Shah is currently working as a professor and head at the Department of Information and Technology, Charusat, Gujarat. His research interests include information security, computer architecture, and cloud computing. Welcome, sir, for today's session. And now we will begin with the participants.
Yeah. Thank you.
So the first paper title is AI-powered web-based diabetic retinopathy detection using CNN-VIT assemble model. This paper will be presented by Nandita RT from Sona College of Technology, India. I request Nanditi ma'am to please start with your presentation. Nandita ma'am, could you please start with your presentation? You're there in the meeting. I'll make the announcement once again. Architectural innovations in AI-driven automation from natural language prompts to local task execution is the paper title. And this paper title will be presented by Tejas Vaij, Kriti Verma, Vikas Verma, Sonali Patil, Azam Usami. If any of the co-authors are present in the meeting, please start with your presentation. I think we'll proceed to the next one. So the next paper title is Comparison of Image Acquisition Devices for YOLO-based Insect Detection, a Performance Analysis. And this paper title will be presented by Min Hu Lim by University Malaysia Sabah from Malaysia. I request ma'am to please start with your presentation.
Yeah. Hello, can you hear me? Good morning.
Yes, good morning, ma'am. I can hear you.
Okay, I would like to share screen. I have sent you a
Yes, I'll
request.
stop sharing my screen.
Okay, let me get into my screen. Give me a moment.
Excuse me, ma'am. Am I audible?
Yes.
Okay, ma'am. Can I start or I should have to wait?
Ma'am, let just this paper title get completed. Then after that, you can have your presentation.
Okay. Okay, let me wait. Okay.
Yes.
Okay, good morning, CD and Dr. Parth. My topic for today is comparison of image acquisition devices for YOLO-based insect detection, a performance analysis. I'm the main author, and we are affiliated to Institute for Tropical Biology and Conservation from University Malaysia Sabah, right? Abstract, the objective of our study is to compare two imaging methods, flat bed scanner, Epson Perfection V850 Pro, and a smartphone, Samsung Note 10, for capturing insect images on sticky traps for YOLO-based detection. Okay, we started our research by annotation and training from the insect images, where we have annotated them up to taxonomy level, order level. Okay, it was done by two entomologists, and images were trained using YOLO version 11. The evaluation was actually using mean average precision, MAP, precision and recall. And lastly, we tested our result using a one-way ANOVA. Okay, our key findings: there are no significant differences were found between models trained with scanner and smartphone images in the overall picture. And for device-specific result, the scanner performs significantly better than the smartphone in detecting smaller objects like Sarcoptera. Sarcoptera is a type of very small book lice. Okay, this highlight the importance of imaging devices selection in deep learning application. Okay, so we go into the introduction first. Integrated pest management is an approach that monitors the diversity and abundance of insect pests to decide on the type of control or intervention. However, in the identification process, it was very labor intensive and time consuming. Therefore, we look into the alternative of using computer vision and deep learning models to solve the issue. Nevertheless, the variety of sensor and devices that can cause the image acquisition process to differ and affect the performance of the model vary. So therefore, in our study in IPM, so we have this data collection, and for the image acquisition, we are using a scanner and a smartphone for comparison. In this study, we investigated the performance of YOLO 11, version 11, to detect arthropods, which is the insects, for the images we have captured with both devices. In our literature review, we have stated that in the insect identification and challenges, traditional methods like microscopy, DNA barcoding are accurate but require specialized training, expensive equipment, and time. But there are also alternatives like community-based platform, iNaturalist, Bug Guide, or Field Guides that offers accessibility but have variable accuracy. So in the deep learning space, there are options of traditional learning, machine learning, deep learning, and the recent advancement in machine learning is actually YOLO, you only look once. So a major challenge in AI-assisted insect identification actually varied using the devices. So let me bring you to the methodology. First, arthropods samples were collected from the insect-like traps in the urban areas. Image acquisition, we actually, for the first set of data, because we are comparing the scanner and smartphone, so we scan using the Epson Perfection V850 Pro scanner, and we have collected a large data set. So all these insects, they were annotated manually, okay, in the CVET, and we've used them to develop a model from the YOLO V11. The same method, the same duplicate of collected field sample will go through the smartphone for image acquisition. Okay, We also use the same method in the CVET for the annotation, and also YOLO V11 for model development. So in terms of annotation, just now I mentioned that we have used two etymologies to do so. Our annotation, we didn't go up to species specific. We took the order level. For example, for housefly, right, this is the order Diptera, okay? Let's say for bees, they are from the order of Hymenoptera. That is how the annotation happened. So for the model development process, okay, image acquisition, we have used the scanner and smartphone. Data set were annotated in CVET. Model development actually happened in RoboFlow and Google Colab. We evaluated the performance using MAP, precision, and recall. And finally, we used the one-way ANOVA to review the significance differences between the results from our model performance. So let's look at the results and discussion in our data set. We actually have a data set consisted of 69 sticky cards collected in last year from from 5 different urban locations. So with 24,674 insects from the 7th order, which is from the scanner, okay, and it has a slightly higher number of annotation compared to the smartphone data set, which contains only 12,796 insects from the 7 orders. Here, the graph actually shows the the breakdown between scanner and smartphone annotated data for different insect order levels. Just now I mentioned housefly is actually in the Diptera order. So let's go into the model performance and evaluation. The result shows that the YOLO V11 model trained with smartphone images has high accuracy in predicting scan images. Okay, our results, which we derive from scanner and smartphone, capture data and cross prediction method by mixing the scanner and also smartphone capture data in the test set. So this is how the prediction was done by mixing up the data set from the different image acquisition. And also our finding was the overall significant performance of the device. Both devices are not significant based on our one-way ANOVA. So, however, when we go into a slightly more specific performance, we actually see that the scanner model is able to detect very small insects like Sophoptera. Sophoptera, they are basically book lice, bug lice, which is very small in size. Okay, when we look at the result, the smartphone while the smartphone model basically did not
Ma'am,
make any prediction here.
hello.
Yeah, yeah.
Ma'am, sorry for the interruption, but we are past the presentation time. Can we please get to the conclusion?
Okay, so this is the last conclusion. The choice of imaging devices has no significant impact on the overall YOLO version 11 performance, but the smartphone trained model performed better on scanned images due to more comprehensive annotation. The scanner trained model excel in detecting small insect orders, while the smartphone struggle with such classification. Further research should explore hybrid approaches to leverage both devices for improved classification accuracy. Okay, do I need to, this is the end of my slide. Do I need to unshare my screen? Okay. So, is there any question for me?
Yeah, so good presentation, Miss Lim.
Thank you, Doctor.
Yeah. So that can you move back to the previous slide of result?
Which one is that?
No, that table showing that MP1.
Let me share the screen again. this table?
Yeah, okay, this one. So here some values are zero.
Okay.
Next.
Where the
Next.
value 0, we did fill in the annotated data set, but there was no detection. It was not detected. Let's make it that way, because when we look at the 0, right, these are let me go to the in front, like Lepidoptera. Lepidoptera, they are butterflies. When you look here, right, Lepidoptera, they have very basically smaller data set, meaning if we were to have some numbers, we will need to beef up the numbers of annotated data set, because based on the insect capture on the gluebots, we mainly have Diptera, Hymenoptera, Coleoptera, and also Sarcoptera.
So does that mean that your detection depends on the some number of data set? Sorry, some number of records in the data set?
This data set, I collected it in the field from the urban environments, because in Malaysia, light traps are placed in the eatery eating areas. So I took the flyboard, so I scan it, and I take the smartphone picture. So it contains the insect diversity that which is inside the eatery environment. Or sometimes these insect sample, they are from the food manufacturer as well, like food factory, grain warehouse. Yeah.
Okay, thank you.
Thank you.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter. Nandita, ma'am, you can start with your presentation now.
Can I start my presentation?
Yes, yes.
Okay. Yeah, I'm Nandita and I'm from Sona College of Technology. I'm gonna present the topic AI powered web based diabetic retinopathy detection using CNN VIT enzymal model. And my teammates are Lakshita, Madhumita, and Kritika. And my mentor is Sendar Kumar sir. Okay, let me proceed with my presentation. First is the abstract of the project. It is we have used a deep learning based system to design and detect and classify the diabetic retinopathy using an ensemble model combining convolutional neural network CNN and vision transformers from the retinal fundus images. The system enhances model performance through image enhancement, augmentation techniques, and ensemble learning, which will be ensuring the reliable predictions. By leveraging AI-driven analysis, it supports for earlier screening efforts, reducing the risk of vision loss in diabetic patients and making diabetic retinopathy more accessible and effective. And diabetic retinopathy has 5 stages of detection, which is first is mild, and then second is moderate, third is severe, and fourth stage is proliferative stage, and fifth is no DR stage. Then the introduction part. In the introduction is about, it is one of the serious complication of diabetics which will be affecting the eyes. It occurs when blood sugar level damages blood vessels in the retina. If it left undetected, it can lead to partial or complete vision loss. Globally, millions suffer from diabetics, and early detection is vital to prevent this blindness. However, the current screening process is manual, time consuming, and heavily dependent on the availability of trained ophthalmologists. To address these limitations, we developed a diabetic retinopathy system that automates diagnosis using deep learning techniques, especially using convolutional neural network and vision transformers. The system aims to improve diagnostic speed, accuracy, and accessibility for larger populations as well. Scope of the system. The primary goal of the system is to assist ophthalmologists, healthcare professionals, large scale screening programs by providing an AI driven diagnostic tool. This system ensures faster diagnosis, reducing the workload of the doctors, improve accuracy through automated image analysis as well. Scalability, making it suitable for nationwide screening programs, especially in under resourced areas where access to specialists is limited. Ultimately, the system empowers early detection, timely treatment, and prevention of vision losses. Challenges in the existing system. Before building our model, we identified major shortcomings in the existing system. Manual diagnosis is not only slow but also varies based on human interpretation, which can lead to inconsistencies. Traditional machine learning methods often rely on handcrafted features, limiting their ability to generalize well across different image sets. Early detection of DR are subtle and difficult to detect without advanced tools. Many existing models perform well only on specific datasets but fail when applied to images from different sources. This is called as poor generalization. These challenges guided the need for a more robust, scalable, and intelligent approach. Need for the proposed system. To overcome these challenges, we designed a system with the following key components: ResNet 50 CNN based model, a deep convolution neural network used for extracting spatial features from retinal images. Known for its residual connection, it helps in deeper learning without vanishing gradients. Vision transformers, unlike CNN, which focuses on local patterns, VITs look at the global image context through attention mechanisms. This allows the model to capture relationships across the entire image. Image enhancement. We apply techniques like Gaussian filtering for noise reduction and contrast adjustment to highlight important features in the retina, such as microimages and hemorrhages. Ensemble learning by combining ResNet 50 and VIT predictions through weighted averaging, the model leverages both spatial and global feature, improving overall reduction accuracy and scalability and cost effectiveness. Once trained, the system can be deployed in clinics and rural health centers, offering fast and affordable screening without needing an expert on site. Next part is the methodology part. The workflow of our system is as follows. First, data processing. Retina front images were cleaned and enhanced using Gaussian filtering, which are to remove the noise, contrast enhancement to improve visibility of the retinal structures, augmentation techniques like flipping, rotating to increase the dataset diversity, normalization, which ensures consistent input. Next is feature extraction. ResNet 50 focused on learning fine details from the retinal image. VIT provided a broader understanding of global patterns, such as structural changes across the entire retina. And then model ensemble is done using predictions from both the models were merged using weighted average, where more confident models influence the final predictions mode. This boosts robustness
Hello.
and yeah.
Ma'am, sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
Okay. This is the result analysis part. In this, as I have mentioned earlier, there are 5 stages of DR I have mentioned. First is no DR, the patient will not be having diabetic retinopathy. And the second one is the first stage, which will be the mild stage. And second is the moderate stage. And third is the severe stage. And fourth is the proliferate DR. These are the stages of DL, and we will be detecting this. And come to the result analysis part. In result analysis, we have achieved 97 percentage using vision transformers. Sorry, I have achieved CNN using CNN. I have achieved an accuracy of 97 percentage, and using vision transformer, I have achieved accuracy of 95 percentage. While ensembling, I will be ensembling the CNN and vision transformers. I have achieved the model accuracy of 98 percentage, which is the highest accuracy. And when it comes to the conclusion part, the diabetic retinopathy project demonstrates the potential of deep learning in medical imaging for early and accurate diagnosis. The ensemble approach proved to be most effective, highlighting the benefits of combining multiple models. This AI-driven solution can assist healthcare professionals in detecting diabetic retinopathy more effectively. Future work can focus on improving model generalization and real-world deployment to enhance clinical applicability. That's it. I have completed my presentation. Any questions?
What is the size of data set?
It's 10,000.
10,000. Okay, so
Yeah,
it is sufficient to get this much of accuracy?
yeah, it's possible.
Mhm.
We have done data augmentation,
Mhm.
so it is possible to get an accuracy.
Mhm. Okay.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter.
Okay, thank you.
So the next paper title is Architectural Innovations in AI-Driven Automation, from Natural Language Prompts to Local Task Execution. And this paper will be presented by Tejas Vaich from Pimpri Chinchwad College of Engineering, India. I request Tejas to start with your presentation. We'll just start with the next presentation. So
Ma'am,
the
can we
next
leave the
paper,
meeting?
ma'am, could you please stay till the end, closing remarks?
Okay,
We have some instructions to give at the end.
okay.
So the next paper title is Cultural Readiness Assessment for HRM 4.0 for Plastic Manufacturing SMEs. And this paper title will be presented by Suresh sir from Amrita Vishwa Vidyapeetham, India. If any of the co-authors is present of this particular paper, you may start with your presentation. Or we'll proceed to the next one. I think we should go on to the next one. So the next paper title is Deep Learning Based Crop Pest Detection and Management System. And this paper title will be presented by YG Ramdarshan Reddy from Amrita Vishwa Vidyapeetham, India. Sir, if you're there in the meeting, can you start with your presentation?
Hello, am I audible?
Yes, you are audible.
Yeah, thank you. Is my screen visible right now?
Yes, sir, your screen is visible.
Okay, thank you. Good morning, everyone. I'm Ram Darshan, and today I'll be presenting our project titled Deep Learning Based Crop Pest Detection and Management System. Agriculture reforms are the backbone of our country, and pest management is a key challenge. So we set out to build a solution that combines computer vision and deep learning to accurately detect pests and guide farmers in handling them effectively. Problem statement. The agriculture industry suffers major crop losses every year due to pests identifying pests. due to pests. Identifying pests early can help take corrective actions, but traditional methods are manual, time consuming, and are prone to errors. Our objective is to design a system that automates pest detection and provides meaningful recommendations, not only to improve efficiency, but also empowers farmers with quick insights. Dataset. We have worked with a dataset containing of 12 major rice crop pests, likely rice stem borer, gall midgets, etc. And we initially trained our classification models on all 12 classes. Then we have narrowed it down to 4 major pest classes: fruit borer, gall flies, locusts, and stem borer. For object detection with YOLO. Each image was resized to 416 cross 416 pixels to maintain consistency and optimize training. Pest outbreaks lead to crop failures, affecting food supply and causing financial distress to farmers. With the rapid growth of AI, especially deep learning, we now have tools that can identify visual patterns in complex images, perfect for pest detection. Our system uses image-based input and provides real-time pest classification, detection, and advice. The importance. Every pest detection helps in improving yield, reducing pesticide overuse, and lowering environmental impact. It can also help farmers save money and protect crop in a sustainable way. By automating detection and integrating decision support, we can bring precision agriculture closer to the grassroots level. Our objectives are accurate pest detection, comprehensive pest identification, interactive query system, effective recommendation for prevention, effective recommendation for control. Here's an overview of our system. It starts with the image acquisition either through upload or camera. The image is passed through the YOLO V8 model or the deep learning based model for detection. Based on the pest identified, relevant data is fetched using scraping and AI web scraping tools. The information is displayed on a user interface and users can chat with the bot for additional information. Model selection. We began with a simple convolutional neural network. It helped us understand feature extraction and gave us decent results, but it lacked generalization for complex pest patterns. And this is the accuracy, as you can see here, model loss, model accuracy, and this is the confusion matrix. These are the hyperparameters which we have used. MobileNet. MobileNet became our top performer. It is lightweight, designed for mobile and embedded systems, and balances speed with accuracy, perfect for practical applications in the field. As you can see, we got a good amount of accuracy, 95% over here. And these are the hyperparameters. And DenseNet. DenseNet connects each layer to each other layer, promoting feature reuse and deeper learning, which is accurate. It was slower and heavier. That is the reason we went with MobileNet. These are the hyperparameters which I have used for DenseNet. VGG16. It is known for its deep architecture and consistency, but it is computationally expensive. We for comparison and benchmarking our model. And the accuracy is 86%. These are the hyperparameters. This is the comparison results of each model which we have trained. Why MobileNet? It has the lowest loss. It has a good accuracy. It is lightweight and efficient. There is less overfitting, and it has the best trade-off. Delivers competitive accuracy with minimal complexity, making it a practical choice. We have integrated a chatbot. To enhance usability, we have built a chatbot using Flask, which is when a pest is detected, the chatbot automatically scrapes the internet for information like pest symptoms, biological control methods, chemical solutions, etc. And it gives solutions, human-like interactions, and reduces the need to search manually. This is the user interface for the chatbot which we have integrated. Frequently asked questions. We have developed a separate frequently asked FAQ system. It develops, it scrapes architecture related websites, extracts questions and answers, and presents them in a user-friendly way. This helps the user explore more about the pest behavior and management strategies, especially when new pests are detected. And this is the UI where we have displayed the frequently asked questions. pest information query. We also experimented with Hugging Face transformer model. This uses bird-based embeddings to understand context. Users can type in custom questions about pests and it answers by extracting relevant content from the JSON file which we have provided. We found that the information over here is going to be staggered and not updated. So we went with the web scraping method. This is the user interface. We upload a pest image over here, predict pest. We get the pest name here. This name is pipeline to the frequently asked questions, and all the details of the frequently asked questions about the pest are given here. And this is the chatbot which we have integrated where you can ask questions. Integration of YOLO model. YOLO V8 object detection, we have switched to YOLO V8 for real-time object detection. It allows multiple pest detection in one frame and provides bounding boxes with confidence scores. With the 4x4 grid annotation strategy, the model learns spatial relationships better. We used image augmentation to improve accuracy and the model performed well even on complex backgrounds. The YOLO V8 architecture is that we give an input and it makes the bounding boxes. It predicts and it annotates the image. The dataset overview. The dataset was sourced from Kaggle and mainly consisted of rice pest images. Each image was annotated using RoboFlow tool. We kept 4 major pest classes to reduce confusion and balance the dataset as much as possible. Despite the class imbalance, YOLO V8 performed well in detecting insects.
Hello.
Yeah.
So sorry for the interruption, but we are past the presentation time now.
Sure. I'll make it. This is an example input batch, and this is an example output batch. Evaluation metrics and label correlation. These are the detection results and analysis. All the references. Our project is built upon the latest research in deep learning, agriculture, AI, and image recognition. We reference papers on YOLO V8, MobileNet, and crop pest datasets. All our sources are credible and our implementations align with best practices on our field. To conclude, our system brings AI-powered pest detection to the agricultural frontline. It's fast, accurate, and informative. With future improvements like weather-based prediction, etc., this solution can greatly benefit farmers. Thank you for your attention, and I will be happy to take any questions.
Hello.
Hello, sir.
Yeah, so you made a chatbot to interact with the system, right?
Yeah.
Okay. So the chatbot gives the answer in the English language, right?
Yes.
Okay. So my question to you is that as you are basically making this application for the farmers, right? So how farmer would have a knowledge of, like generally farmers are not having a knowledge of English language, right?
Yes, sir. I
So
get
how
it.
this can be useful to the farmers then?
So we have integrated the chatbot using web scraping methods. So like if you search in like my mother tongue is Telugu. So if I search in Telugu, I get Google results in Telugu itself. So it works in a similar way.
So that multilingual support is there. That is what you want to say.
What we did is like we use
Multilingual
Google
model.
API to get the results, sir. That is what we did. So like if you search in Telugu, you get Telugu results.
Another question that you said that that image resizing would be required to run the system, to use the system, right?
I'm sorry, sir. Could you repeat the question?
Image resizing.
Yeah.
Okay. So now if we do the image resizing at that time, the quality may lose, right?
Okay.
How you have tackled that?
We have already pre-processed the image like when we have so the data set is available in 416 cross 416 and when we are training the model itself we have like added noise to that image, resized, rescaled. All the pre-processing has been done and trained we have trained the model using that. So it is already being handled in the pre-processing.
And what about testing?
Sir,
What about testing, real-time testing?
Real time, we have. I didn't get you, sir. What about?
See, for data set, you have already curated everything, right? During
Yes,
the
sir.
pre-processing step.
Yes,
Okay.
sir.
So I mean to say that when you are using this application for real-time data, real-time means set image. Okay.
Okay.
How your application would manage that.
Um,
At that time also you may
uh,
require to resize the image, no?
yes, sir. Yes, sir. For real-time applications, we are using YOLO. So, like even in YOLO, we have done quite a bit of pre-processing in a similar way. So, like when we annotated the images, it will give an annotated image as the it will annotate the image live, sir. So it will be able to detect in that way.
Okay, thank you. Good
Thank,
presentation.
thank you, sir.
Now we'll proceed to the next presenter. So the next paper title is EduConnect, a smart solution for streamlined school administrations. And this paper title will be presented by S. Muhammad Asik from RV College of Engineering, India. I request Muhammad sir to please start with your presentation. You
Yes,
are
ma'am.
there in the meeting.
Yes, ma'am. Yes, ma'am. Let me share my screen.
Yes.
Uh, is my screen visible?
Yes, sir.
Good morning, everyone. I am honored to be here at Digitally at 9th International Conference on Information Communication Technology for Intelligence System. Today, I would like to introduce EduConnect, a digital platform built to modernize government and government-aided school, especially in under-reserved areas. EduConnect streamlines school administration, improves teacher-student parent communication, and uses AI to create a more interactive and inclusive learning environment. Let me introduce my team. We are a team of 7 people. Prafula SB, Deepamala N, Saumya A, S. Dhanush, S. Mohammad Ashik, S. Prajwal Narayan, and Sumit S. Tantre. Coming to the problem statement, schools continue to face significant challenge due to outdated administrative process, ineffective communication, and limited access to digital learning tools. Schools still rely on paperwork for admission, teacher assignment, and student management. Students often hesitate to ask questions in class. Inappropriate message or harmful message on the existing platform disrupt the learning, and current system lack AI-powered content filtering. Important school announcement often fail to reach the students and parents on time, particularly in rural areas of India. Students are forced to use external apps or phone numbers to connect with teacher, posing a significant posing a risk to safety and privacy concern. Parents and teachers find it difficult to monitor students' progress due to manual tracking, which is often unclear and inefficient. Coming to the proposed system, in order to mitigate these issues, we begin with the secure authentication using JWT-based token authorization. We digitize the key processes like admissions, teacher assignment, and student record. To enhance the communication, we have a built-in secure chat system for the communication between teachers, students, and parents. To maintain a respectful learning environment, our AI-driven NLP model filters inappropriate content, ensuring safe discussion. We also automate the progress tracking and grade calculation, reducing teachers' workload and providing students with real-time insight. We keep everyone updated with the notification of school events, assignment, and test results, ensure no important information is missed. Coming to the methodology we propose, our development process begins with the requirement gathering, where we gather the input from the end users, teachers, students, and parents to understand their challenges in the education system. Based on these insights, we move to the system design, where we structure the software. Next, we have a database design incorporating both relational databases and non-relational databases, which is MySQL and MongoDB respectively. The model design is our core. We leverage modern web technologies such as React.js for interactive frontend, Node.js for backend, and Redux for the efficient state management. For the real-time features like chat and video conferencing, we integrate Socket.io, ensuring seamless communication between student, teachers, and parents. We conduct we have the NLP based chat filtration capability, where we filter the harmful contents, which is trained on a huge data set more than 1 lakh, where we use TF IDF vectorization and use random forest in order to filter the messages. So we have an activity diagram which describes the workflow of The process starts with the user login, where the credentials are verified. If it is incorrect, an error message appears and a user can recover their password via email. Once authenticated, users are categorized as administrator, teachers, or student. Administrator can manage user by selecting a user type, entering details, linking teacher, assigning student to counselor, and adding notices. Teachers have multiple functionality, as you can see in the diagram, including updating personal details, managing doubts, and altering test details. They can answer the doubts or they can delete the doubt, upload the question paper and student score with respect to the question paper, and directly communicate with the students via messaging, via chat, and video conference. Students, on the other hand, can update their details, view doubt, ask doubt, assess the test score. Their messages are monitored using offensive language detection model, which is a novelty in our project, to ensure a safe communication environment. Let us look into the working of our project with the snapshot of our websites. In our system, there are 3 user roles: admin, student, teacher. They can log in into our system using user ID and password. If they forget their password, they can click on forget password and they can enter the email where they receive the option in order to reset their password. This is the dashboard of EduConnect, where we have most relevant information like the number of teachers, the number of students, the number of staffs, admins, classrooms, school buses, notices, and dates. As you can see, all the important notification which is sent by the admin are showcased under the school notices. Coming to the admin page, admin has the capability of adding the student with all his personal information, adding one more admin or the another admin, and adding teachers. This mitigates the problem of the manual registration, which is followed in 30% of the government school in India. Coming to the teacher assignment, the admin can assign a counselor to the set of students, and he can assign a teacher to a particular subject and particular class. He can add a notice which can be received by the student, teacher, as well as parents. Teachers and students and admins all have the opportunity and to update their profile. The teachers can upload the question paper and the score mapping with respect to the particular question paper, and both these are in the form of CSV. So coming to the video conferencing part, here as you can see in the figure, a student or a teacher can set up a call with a unique meeting ID. When a teacher or a student clicks on the call, the other people get the notification of to answer the call or decline the call. Then we can is my screen visible?
Yes.
Yes.
1 second. Okay. So coming to the chat message window, a teacher can select a student or student can select a teacher and can have a one-to-one conversation, and this mitigates the issue of moving to the external tools or external platforms. Coming to the doubt functionality, a student can ask a doubt with the necessary details, doubt, subject, and the teacher for whom he wants to ask. In the doubts, you have all the doubts which are being asked, and in the solved doubts, you can see which are the doubts which are solved. Coming to the solving doubt functionality for the teachers, the teacher can view all the doubts, whether he can answer the doubt or he can delete the doubt. If he is going to answer the doubt, he can answer in the dialog box and post it. The innovative component, which is the field
Hello.
machine learning based, yes ma'am.
Sir, sorry for the interruption, but we are past the presentation time now.
Yes ma'am, I'll conclude. Yes ma'am, I'll conclude.
Yes.
Yes, we can add when user adds the doubt. As you can see, the sentence that you are stupid, it will block the offensive text. The student can view all the test result for the test he has written. Here is the machine learning the performance. As you can see, we have trained multiple machine learning algorithms and we have got a good accuracy of 99.89 for the training and 95.47 for the random forest, which is used for content based filtering. This is the qualitative analysis. As you can see in the diagram, the response given by more than 50 teachers, students, and principal, we found 14% like the chat features, followed by the doubt clearing system and important notices. Coming to the conclusion, EduConnect helps in reducing the manual workload in the current education system. It offers the AI-powered capabilities, video conferencing, chat messages, and many more. Thank you. Thank you for the opportunity. Feel for any question.
No
Thank you.
question.
Hello.
No
Hello,
question.
sir. Thank you for your presentation. If there are no questions, then we'll proceed to the next presenter.
Yes. Thank you. Thank you.
So the next paper title is Architectural Innovations in AI-Driven Automation from Natural Language Prompts to Local Task Execution. This paper will be presented by Tejas Vaich and by Kriti Verma. Ma'am, you're there in the meeting, right?
Hello, am I audible?
Yes.
Yeah, so can I start?
Yes, you can start with your presentation.
Just a second, I'll share my screen. Um, is the screen visible?
Yes.
So, hello, everyone. This is the presentation on architectural innovations in AI-driven automation from natural language processing prompt to local execution. So, we are team members, me, Kriti Verma, Vikas Verma, Azam Usmani, and we are guided by Dr. Sonali Bhatt. The contents of the PPT are first we will explain the problem statement and the solution,
The
objectives, and scope
presentation.
of the project, the use cases of the project.
Yeah, please continue.
Hello. System architecture of the project, then technology stack, the tech stack, implementation, and then conclusion and references. So the problem statement is like traditional PC management requires manual command execution and complex navigation, making it inefficient, time consuming, and challenging for the non-user. Basically, uh, like some tasks from a PC may require you to have good understanding of the system, good understanding of the desktop application, and all. And that's something that non-technical users and users that are new to the PC, or even some of the user who cannot really get to the complete completion of that. That is problem. So AI powered automation that is
I think
the
there is
front
some
of
issue
system
in
to
the
handle language.
slide. Hello. There is some issue in the slide.
Hello,
I'm still on the content slide.
just content. Uh, can you repeat? Hello.
Still I am on a content slide. એની વેબસાઇટમાં ઉપર જ પહેલા જ પેજ ઉપર 4 ચાલુ છે.
Hello. Sir, could you please just reshare the PPT? The previous slides were not moving.
Application. Hello. Is my screen is visible,
Hello.
right?
No, sir, we cannot
Hello.
see your screen. Could you please reshare it?
Oh. Join. Hello.
Hello. Sir, we are not able to see your screen.
Am I audible to you? Yeah,
Yes.
1 second. I got the button again to share the screen. Yep, now it should be. Sorry, sorry for this. So
Yes, it's
the
moving
solution
now.
that we are, yeah, The solution that we are proposing is that we have developed an AI-powered desktop application through which through NLP and through just normal text commands, you can operate your PC and do multiple tasks in your system. Objectives that is to develop an AI assistant that enables seamless system management. It should help in coding, error detection, code generation. It should help in automating some default things like file management, processing, monitor, software updates. It should enhance the security for the system and all of it. Scope of the project, it has a vast scope, but in if I have to explain in short, so anything which involves giving commands to a system or writing a script and running that script, that can be done through the project. And this is what some of the mentioned things we have like found out that our system is capable of doing with a very good accuracy. That AI powered system management, so file management and like getting up all the information of the system and all, coding and code generation, code correction and all, file and directory operations, so creation and then deletion and all overall management of the file, security and antivirus integration, so it can scan viruses through your system, and this command execution. So we have this feature like this is how it works on your project. So through the NLP commands, we can actually use your system and then cross-platform.
Hello.
Hello.
Sir, are you done with your
Is there
presentation?
some? No. It, I'm still doing it. I think there is some internet issue on my side because of which the website is reloading. Like the Zoom meeting is getting delayed. Just a second. I'm not able to see how it's going to be.
I'm not getting anything.
Sir, if there are any
Any?
technical issues, even we can present on your behalf. You can just send me your PPT and then resume with your presentation. Hello. I think we will proceed to the.
Sam,
Let's proceed. Okay.
uh,
Hello.
I will
Sir,
share
are
it.
you trying to?
I mean, maybe you can continue our meet like our presentation afterwards. After let me just.
Yes, okay, that will be fine. Then we'll start with the next presenter. So the next paper title is FD hand washing machine for disease preventive and hygiene practices during pandemic. And this paper will be presented by S. Radha from Chaitanya Bharati Institute of Technology, India. I request Radha ma'am to start with your presentation. I'll stop sharing my screen.
Okay, madam. Good morning to all. Our topic of interest is fog disinfection. FD stands for fog disinfection, hand washing machine for disease preventive and hygiene practices during pandemic. And we are from CBIT, Chaitanya Bharati College, Hyderabad. And our co-authors are Mayan, Onkar, Nagadevi, Nagabhushanam, Vasant, Jahna Vardhini, and Murli Karthik. This is our prototype. We are expecting the final prototype to be like this. We are designing this using Arduino board, fog maker, and other small electronic components like screws, bolts, buttons, switches as usually required. And here we will be giving a water tank where the water will be refilled periodically. Based on heating, it will be converted to fog. And when the user applies soap and expose the hands in this fashion as in the prototype for 5 to 15 seconds, then all the fog will be sprayed on the hand and all the soap will be washed off. Thereby, the water resource usage is also less. And this can be installed in all educational institutions, airports, theaters, and other organizations. This saves time of the user as well as the water resource. And this is the literature survey. And we have thought of this after referring these papers. Based on improving the hygiene practices, the pandemic spreading can be concentrated, and we can introduce a new habit of hand washing in whichever country it may be or whichever people it may be. The habit of new habit of hand washing can be introduced slowly, and it can help us during various pandemics that is seasonally coming up. Then health policies, it can be introduced as a health policy also. And hygiene, with the disability or without disability people, their maintenance of hygiene can be concentrated. And implications of water usage during pandemic and water recycling also. For drinking water, when we do recycling, the wastage what is going on, that water can be recycled for this hand wash purpose, which will be effective usage. And handling pandemic, the previous slide, it is about hygiene practices, how to handle the pandemic. The reduce of water usage, over usage can be controlled, and sanitation can be improved. And then sanitizer can be used instead of soap hand wash, and TikTok videos can be popularized to give awareness of hand washing and making this habit. Then infection control, infection rates, then public health can be improved, and these are realistic methods. And then coming to the residential, sometimes in hostels, etc., a big crowd who are staying, who are away from homes, their health can be taken care effectively using this process. And quality assessment, how far the hand wash quality is improved, all this can be affecting the pandemic control. Then coming to the washing principles, improving the washing principles, in the entire setup, the time and battery usage can be controlled, and COVID or other pandemic spreading can be inhibited, decreased. Then the protection, the motivation for people to keep themselves protected, that can also be concentrated. And hand hygiene, sustainable development goals, this is a part of sustainable development goals. And then different departments we can concentrate, like healthcare centers, or as I told, educational and theaters, malls, everywhere we can keep this device. And then life quality improvement can be done, concentrated. And then hand hygiene, already I told, and reduction of pandemic condition. These are the improvement in washing principles. And the motivation behind this, we came across a paper from Bangladesh. They concentrated on 2,000 participants, and if each candidate wash hand 5 times a day, and with soap, without soap, they have concentrated, and extra scrubbing is required if soap is used. In that process, if the person keeps the tap on throughout the washing, 1.7 liters of water is wasted in every usage. Totally per day, 14 liters of water is wasted by every person. This increases 13-fold the water usage. As a solution, they have came up with these different ideas. Speed of water tap, automatic taps, taps operated with legs, and then while scrubbing hands during hand wash, or fog disinfection. This information are available different country wise or educational institution wise, like that. They have done this analysis. And then the second study, our colleague from biotech department, she was infected with COVID, and she is less than 45 years. She didn't take the first slot vaccine, but she felt after COVID recovery, she felt the joint pains, but she delayed in focusing on it. And later half, she was found, when she found time and went to hospital, it was already the cells were getting damaged in the hip, 2/3 and 1/3 on the left side and right side. And doctor suggested a rod, 2 to 3 replacement, hip replacement she has to undergo on both sides, and she was advised for rest 1 to 2 years. This is a post-COVID or post-pandemic effect. All this motivated us to concentrate in this direction. We want to reduce the water usage and give a cost-effective device and declare whatever the periodic or seasonal pandemics are coming now and then. We want to give some observation on that, how the disease is spreading, what is the intensity, if this device is used, how far it can be controlled. Initially, we have used Tinkercad software and we checked whether it is realizable, possible or not. We have kept the sanitizer holders and then the motors, fans, everything, LCD display, all this we have taken up in the Tinkercad, and roughly we have checked for the realization. If we go for real hardware, how it will be effective or not. The LCD will display what we can fix the time 5 to 15 seconds. User can there are switches user can operate whether want 10 seconds or 15 seconds for that hand wash. And all this display will come in the LCD, and once the time is over, LCD will display, you can remove the hand, so hand washing is completed. All this can be installed in bus stations, cinema halls, colleges, schools, etc. And different pandemics like cholera, malaria seasons also, this will be helpful if it is made as a practice of hand wash. This Arduino board coding this is for sensors, declaration of the sensors. I have put some coding. These are the pin numbers where the sensors will be connected in the Arduino board. Sanitizer holders, everything we have put at the rear end. First, the hands will be sensed, and I will show you the entire setup. And coming to the LCDs, as I told, and mist makers is nothing but we can put the water tank, and that heat will, by heating, the water
Ma'am,
will be. Yes, madam.
Ma'am, we have to get to the conclusion. We are past the
Yes.
presentation time.
Yes, I will close. We can put a sanitizer in the mist makers. Otherwise, we can heat the water and fog can be generated. Water and glycerin can be mixed. If it is heated, fog will come. So like that also we can operate either with water or directly sanitizer also can be put. With Arduino and Keil soft coding, we have done it. And this is the initial setup we came up. And this is the present thing what we have now as of now. This is the almost 90% of our work is completed. And this is the acrylic sheets box, the 2 holes where hands can be inserted, everything. We are yet to do the last 5 to 10% work, the final closing to get the prototype. And it will be in working condition only. And here we are addressing water recycling, water scarcity, frequent hand wash habit, and then cost-effective device, and converting to fog is a little new idea. These are the references. Thank you.
What about power optimization in this?
The batteries and all, we are thinking of to use effective batteries, sir. In that case, power optimization we can expect. Different batteries are there. Batteries operation is there.
Yeah, got it. But have you tested that how many hand wash supports particular battery? Means that during the battery life, how many hand wash would be supported?
No, sir, we didn't test, but we are expecting at least 2-3 months we can hold without replacement of battery, and water refilling a team should take care. But battery wise, we didn't check as of now. How many hand wash and all, we didn't check. Sir.
Water refilling is manual in this case?
Sir, what's
water refilling is manual?
Manual, sir.
So you can automate that as
well. Yes, we are planning it to keep a big water tank outside the box and inside a little small one. We are planning that, sir.
Okay.
Thank you, sir.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter.
Thank you, sir. Thank you, ma'am.
So the next paper title is FPGA-based implementation of 5-stage pipelined RISC-V processor using Xilinx Zinc 7000. And this paper will be presented by M.R. Maheshwar from SRM Institute of Science and Technology. I request Maheshwar sir to please start with your presentation.
Yeah, just a minute. Madam, paper ID 904 also reading, madam. So next you can. 904.
Yes, sure, sir. We can have your presentation at the end
Yeah,
according
okay.
to the sequence. Yes.
Fine, madam. Fine. So
Is my screen audible? Sorry, visible?
Yes, yes.
Yeah. So good morning, everyone. My co-panel, so panel members and everyone. So this is my paper, FPGA-based implementation of a five-stage pipeline processor using Zinc 7000. So here, like the authors are Dr. E. Chitra, Manikanta Pavan, Reddy Balaji, and myself. So we are from SRM Institute of Science and Technology. So basically, so this is the agenda of this PPT. So let's go to the introduction. So in the introduction, so what is RISC-V? RISC-V is a reduced instruction set computing. V stands for the fifth generation of it. So it is a like open source architecture which can be useful in like all type of embedded applications. So RISC-V initially came like it was came like RISC-V internationally came out in 2015. So from then onwards, like it started rapidly evolving. So here is a literature review of it. So our project is on implementing this RISC-V architecture. So on Zing 7000 FPGA. So in this literature review, so here in the first paper, as you can see, so this was the simple instruction set architecture. So in this way, basically we have several instruction sets. So here they have given an overview of it. And in the second paper, we can see, so they have developed a 16-bit architecture for the RISC-V. And in the third, so this is the verification part. So this is the post development. So when we will do this design under test and verification. So this that part of the stage. And in the fourth paper, as we can see, like they have addressed about 128 bit processor. So for the RISC-V, and in this in the fifth one, so this is the general user interface. They have developed a GUI for the RISC-V processor. And sixth is a RV16. So that is a 16-bit low cost embedded RISC-V processor. So coming to the problem statement, so why RISC-V? So like so we have talked about what is RISC-V. So now why RISC-V is used. So unlike we have, as we can see, like there are many architectures which are there in every electronic devices. So most of this architecture are mainly proprietary. So because of that reason, so if I want to develop an architecture, like if I want to develop a hardware and if I want to develop a system, so I just need to buy that architecture and I need to develop on it. Or if I need to do some upgradations to that architecture, so at the end of the day, like cost is the main matter for me. So because of this problem, so RISC-V has came up with a solution of getting this whole architecture thing as an open source, such that because of the open source community, like from all of the world, everyone will can easily contribute. So although it has started in 2015, but it is growing rapidly and coming to the embedded industry as well as this the signal processing, etc. So, so the main, so the existing architectures, as we can see in our electronic devices, mainly are computers, if I can say. So the x86 processor is being used, and in industrial side, so in robots, etc. So so ARM architecture is dominant. So between these two architectures, RISC-V is also finding its way to compete. These are main problem statements. So implementation. So this project has been was done in 3 stages. First was the single cycle implementation, and second is the 5-stage pipeline implementation, and third is the hardware of it. So showing the hardware using FPGA. And in the first phase, as you can see, so this is the single cycle architecture. So single cycle mainly like a single cycle means, so every instructions we have, so it will take single clock cycle. Coming to the hardware point of view, so our Z board, we are using a Digiland Z board. So Z board has a clock cycle of 10 megahertz. So with respect to that, so for every single clock cycle, for every 10 nanoseconds, each instruction will happen. So mainly this have a program counter, an instruction memory, register file, ALU, and data memory. So let's say if I have an instruction, so this program counter will take care of all the instructions which we give to the processor. So all these instructions will have some address. So that address will be stored in the program counter. So as there is a 32-bit architecture, so we are using hex code for it. For the 32-bit binary, we convert it to hex, and this hex is stored in the program counter. So after completion of every instruction, this program counter increments its address, pointing to the next instruction. And coming to the instruction memory, so this instruction memory is where all the instructions have been loaded. And from so the program counter will point to the address in the instruction memory, such that the instruction will execute. In the register file, we have all the registers. So RISC-V offers a total of 32 registers. So in which almost 25 of them are usable. So which we can use it for our temporary or storage purposes. And register and ALU, as we know, like arithmetic and logical unit, it just does this arithmetic and logical operations. And data memory is where we are going to store our data. So apart from this, so coming to the second phase of it, so this is a 5-stage pipeline. So why again we have a single stage pipeline? So why we are going for five-stage pipeline? So the reason for this is, so if we have like small like set of instructions, then it is fine for a processor to do all the operations. But to streamline all the operations and to make it smoother, we have stage pipeline architectures. Usually we can see this for complex
Hello.
architectures. Yeah.
So sorry for the interruption, but the presentation time is over. Can we please get to the question answer section?
Yeah, sure. These are the results for the single stage architecture. So as we can see, this instruction we have used the store word instruction. So which we have taken register ninth register, so X9 register, which contain the data of 20. So this got added to an immediate value 8, and from from this result, from this address, basically the whatever the data is there, that will be written. So as we can see from data memory, in this register we have data of 2, and this is going to be the result of this instruction. So in the similar way, pipeline is also there. So pipeline will have all the five pipelines of like 5 stages. So like all the instructions will be there present, like all the fetch, decode, execute, memory and register write back will happen simultaneously. So after 5 clock cycles, so all of this process will execute simultaneously. And this is the hardware implementation of it. So as soon as we get the output of from the processor, so that will like directly go to the OLED. So this is an external peripheral that is present on the Z board. So conclusion is, so mainly RISC-V is offer a low power architecture. So this is basically used like in normal consumer electronics, which where like power is also one of the main priority. So RISC-V offers like all these kind of solutions. So future improvements can be done for the OLED display, and for implementing RISC-V on Linux environments, which can be the bridge between hardware and software. Yeah, thank you for giving me this opportunity. These are references. So yeah, if you can have any doubts, you can ask me.
Yes, Mr. Maheshwar, see
Sure.
here, you could not get that RISC-V has already that multi-cycle pipeline.
Yes, sir.
What is your contribution over there?
So mainly we targeted on hardware implementation of it. Multi-pipeline is there, but all these papers which we saw, they haven't been implemented on hardware. Or we are further also extending for implementing Linux on it, Linux on this architecture. So for that reason, we have this.
Mr. Maheshwar, RISC-V is already a hardware.
Yes, sir.
And what do you mean by implementation in hardware?
So mainly RISC-V, like that architecture is there, sir. Like, but on FPGAs, it hasn't been there. So that is basically which we.
FPGA is a different thing. RISC-V is a different thing,
Yes, sir.
right?
Yes, sir.
What you want to convey over here that I'm not getting.
So
Because see, pipelining is already there in the RISC-V. Okay. And it also supports the multi-cycle design. Then what is your contribution?
So mainly like interfacing it with FPGAs.
Okay, then
so like further we are like planning to go for like basically like implementing Linux on this RISC-V, such that like we can like have a bridge between both of them.
Linux on RISC-V. What does it mean?
So basically on this architectures, so as we can see, like all the instructions which we are having. So basically the software side of this RISC-V. So we from through Linux we are going to we wanted to give the instructions or give the code for it for the processor.
I think there is some confusion. Anyway, you please go through that. Okay, thank you.
Yes.
Thank you, sir, for your presentation. Now we'll proceed to the next presenter. So the next presenter is the paper title is Logo SAM Enhancing Prototyping Networks for Medical Image One-Shot Segmentation Using Local Global Encoder Integration and Visual Prompting. And this paper title will be presented by Khang Ta Jia from Ho Chi Minh City University of Technology, Vietnam. I request sir to please start with your presentation. I'll stop sharing my screen.
Good morning, everyone. Just waiting me for share the screen.
Yes.
So, could you see my screen well?
Yes, sir, we can see your screen.
Oh, okay. Good morning, everyone. I'm Khang from Ho Chi Minh City University of Technology. So today I will represent my team to present a study about one-shot segmentation, and we will present a new framework, which we call Logo SAM. This is the content of my presentation. Let's talk about the motivation. In the current segmentation task, the segmentation task can vary depending on the clinical scenario. So the variation in task definition make it challenging to develop many different segmentation model for each task. And also the deep learning for segmentation relies heavily on label data. So few-shot segmentation address this by learning similarity of latent features from limited examples. The idea comes from the prototypical networks for few-shot classification, in which we extract the mean feature vectors of given examples and then classify unseen items by comparing the similarity of the features with the prototypes. From that idea, we present the prototypical networks for one-shot segmentation, in which we decide to classify each pixel in the query image as a prototypical network for classification with the support set given is the set of pixel features. So the prototypical networks rely heavily on the feature extraction, and we have two main approach for this phase, which is convolutional neural networks or transformer-based. However, convolutional neural networks should go with the global contextual understanding, and transformer-based require many data for perform well. So in this study, we'll apply the gated axial attention, which is an adapt transformer for better segmentation, in which it needs less data than the transformer-based vision transformer. Moreover, currently the segmentation anything model has shown some performance in image segmentation, which if we give it a good prompt as the bounding box, it will segment the things that we want really well. So our contribution will be threefold. Firstly, we'll design an embedding function, which is an encoder that can capture both local pattern and global dependency in a medical image. Moreover, we incorporate the prototype learning technique into our one-shot segmentation. And finally, we use the similarity maps to extract the prompts for SAM for the generate the final segmentation. This is the summary of our study, which we have given a query image and a support set is include support image and support mask, and we will generate the query segmentation for the query image. For a dataset, we use two type dataset, which is the SAP dataset and the Chaos T2 dataset, which include the CT scan and MRI scanner. Then we will make the final dataset with the constraint is that the class in the training set will not include it in the test set. The related works, the most important study that we have referenced is that the model called SG1, which firstly introduced the mass average pooling for one-shot segmentation. For more example, you can extract the prototype from the support set, and then you will compare it with each pixel level features in the query features. If the quotient similarity is near, mean that they are the same, so the value is near by 1, mean that the class of that pixel is 1. Otherwise, the class of that pixel is 0. We will also apply actual attention for implementing our encoder. However, with the small scale dataset as medical imaging, positional encodings may be inaccurate learn. So we apply the gating mechanism by adding some gating parameters to control the influence of positional bias. So we found that by this way, our model could learn to encode the medical image better. Now let's move to our proposed method. This is our baseline, which includes 3 main parts. Firstly, the logo encoder, the logo which means for local logo, the prototype extraction blocks, and the final is the prompt extraction for SAM to generate the final segmentation. Our philosophy is that we have to extract both local patterns and global dependency from a medical image. So that's why we divided the encoder into 2 branches, the global branch, which we pass the whole image into the actual attention block, and the global branch, which we divided into 16 parts for the local branch, and then we reassemble it into the initial shape. Finally, we add them together and move to a convolution layer for getting the final feature maps. We also introduced the class level prototype extraction, in which we have to multiply the support features with the support mask before getting the average pooling. By this way, we just save the features from the class 1, and we on up the feature in order zone will be 0. So the prototype will just save only the features of the class that we want. This is the algorithm that we extract the prototype. We extract 2 type prototype, which is the local prototype using average pooling, and the class level prototype, which I have introduced before. For the core segmentation, for each class, we'll extract a set of prototype, which include local and class-wide prototype. From that, we use the quotient similarity to generate the similarity maps by this diagram. For each pixel in the query feature, we will use it to get the similarity score with the set of prototype for that class. From that, we generate the weight by submax and then combine them together by the addition. This technique is near.
Hello. Sir, we are past the presentation time. Can we please get to the question answers?
Okay. So this is our result compared with the state of the art, and this is our demo. Which first column is the support image, the second column is the support mask, the third column is the worry that we want to segmentation, and the two last column will be the predicted value and the ground truth. So in conclusion, we have present architecture for one-shot segmentation, which we combined prototype learning with the local global encoder. We also apply SAM for the last step to extract the prompts and use it for the final segmentation. So that's the end of my presentation. If you have any question, feel free to ask me.
So, a good presentation. How is the threshold decided for the similarity check?
Can you ask again?
How is the threshold decided for the similarity check?
In this, you mean in this slide?
Somewhere you had mentioned to check the green pixel.
I will get the each pixel level features is the column vector from the features, and then I will come.
So when you're supposed to match close to one, no? That is what you had mentioned earlier.
I'm so sorry that my connection isn't good enough. So could you type it into the chat?
The green pixel supposed to match to the value close to one. That is what you have mentioned earlier.
Yes. I mean that when the quotient similarity is high, mean that the value will be nearby one. So it will get the class one, and
so what is the threshold value in that case? So sometimes it may happen, it may not match to one.
I will use the value will be in the range of 0 and 1. So I will get the value, and then finally I go to the sigmoid layer. So it will generate the final distribution, and then we could get the final mask.
Okay, okay. Thank you.
Thank you, sir. Now I'll proceed to the next presenter. So the next paper title is Using OCR for the Extraction of Data for Warranty and Receipt Management. And this paper title will be presented by Premdev Dhote from Pimpri Chinchwad College of Engineering, India. I request Premdev sir to please start with your presentation.
Yes, I will start in a minute. Is my screen?
Yes.
So, good morning, everyone. It's a pleasure to be here at the 9th International Conference on Information and Communication Technology for Intelligent Systems. My name is Rohit Dhamale, and I am presenting our work titled Using OCR for the Extraction of Data for Warranty and Receipt Management. This research is conducted in collaboration with my esteemed colleagues, Reena Kharat, Prajwal Dhoke, and Premved Dhote. So let's begin by understanding the core problem. As in current life, we all have deal with bills and warranty cards. So the physical documents are frequently misplaced and damaged. And this can also result in the loss of important physical records. Consider the problems that arise due to print degradation on text over time. Sometimes misplacing a warranty card can also halt the process of repair claims. So our motivation is the need for a reliable solution for accessing the purchase and the warranty cards when needed by converting the critical documents to digital formats to protect consumer rights. So we aim to develop a system that digitizes and manages the text extracted from warranty cards. So let's start with the objectives. Our key objective includes, firstly, to develop a reliable OCR system for extracting text from receipts and warranty cards, even if they are degraded. So, and secondly, to ensure the accurate recognition of critical information such as purchase dates, warranty periods, and product details from those warranty cards. And thirdly, we aim to create a secure digital storage solution for this documentation. Finally, a crucial objective is to implement the intuitive interface for managing and retrieving the digital copies. So talking about the literature survey, so the traditional approach, which was earlier carried out, was on improving the OCR. Basically, everyone focused on improving the OCR. So, but nowadays the focus has been shifted to deep learning revolution, which includes neural networks, CNN architectures, and character error rate, means decreasing the character error and increasing the accuracy. So now I would like to explain the proposed system, which would address this issue, the problem we have discussed earlier. So I would like to explain the system architecture diagram. So first, in the system, we would provide an interface from which the user will upload the image, and in the first step is the image acquisition. After that, in the second step, we would with OpenCV for a build detection and pre-processing, which would extract text. So the third step is text recognition using OCR and efficient text extraction of the information, of the important information which I have discussed earlier, like the dates, warranty periods. And after efficient extraction, we would go with structure storage, which would help us for efficient and advanced receipt handling functionality, which would help us to retrieve the data quickly and efficiently. And the last one, we would ensure the data and security and privacy of the extracted text and the user. So talking about the algorithms, I would like to explain, the algorithms which can be used here are the canny edge detection algorithm, projection profile method, CNN based methods, and layout LMV2, which can be used for the system architecture diagram, which we have proposed. So our bill extraction process encompasses three main operations: image acquisition and pre-processing, and text recognition, and finally extracting the required data for subsequent storage. During the pre-processing stage, which is crucially OCR accuracy, we utilize OpenCV for build detection and image enhancement. This involves applying the canny edge detector to detect bills by identifying sudden changes in the intensity. The contour detection method can be also used, specifically using its functions to isolate the bill as the largest rectangular figure, and then to deal with verifying lightning condition. The adaptive thresholding converts the image into a distinct black and white picture, improving the text background contrast. For text recognition, our system employs Tesseract OCR. Tesseract effectively carries out text segmentation, dividing the image into block, lines, words, and characters, which aids In identifying structured data, it uses a double recognition process to improve accuracy, especially in low quality images. So next, I would talk about the results and impact. So we have evaluated the performance of our system and achieved a overall text extraction accuracy of 89.33%. This significant accuracy highlights the effectiveness of our combined approach of image processing, pre-processing with OpenCV and text recognition using Tesseract OCR.
Hello, sir, we have passed the presentation time. Could we please get to the conclusion?
So these are the advantages which would basically help us to for efficient extraction of the receipt data. So concluding, our research demonstrates the power of combining image processing, machine learning, and natural language processing to revolutionize how we manage and interact with financial documents. So any questions?
What about privacy? I haven't seen any algorithm related to privacy in the presentation.
So we are planning to store all the documents with the encryption in the cloud-based databases. So that way we can achieve the accuracy, achieve the security.
It can also be included in the future scope.
Encrypting the data, that means that you are providing the solution of confidentiality. It is not something related to privacy. Privacy means something else.
Okay, sir.
Anyway, you look into that. Okay,
Okay, sir. We would definitely work on it.
Thank you, sir, for your presentation. Now, Suresh, sir, you may start with your
Yes, sir.
presentation.
Thank you, madam. Thank you, madam. Thank you.
Thank you, ma'am.
My paper ID 904, madam. I will share the.
Yes, you can start sharing your screen.
Yeah. So, good morning. So, good morning, all. Dear faculty members and research scholars and guest members and evaluators. Thank you. I'm Dr. Suresh. My research topic is Cultural Readiness Assessment for HRM 4.0 for Plastic Manufacturing SMEs. I'm the first author and my co-author, Dr. S. Ilango. So, paper ID is 904. So why the cultural readiness is very important. So if implementing for HRM 4.0, the readiness factors are very important. So if they reach the organization is ready for the implementation, then if they go for the implementation, then smooth implementation is possible in HRM practices. So here we took for the case study of the manufacturing, plastic manufacturing SMEs. So here the cultural focus, because the cultural is a major important, one of the key parameter for the transforming this from one system to the another system. So the employees culture, work culture, and work system, that is a very important for the transformation from the ordinary HRM practices to the HRM 4.0. So that's why we took this focus on the cultural readiness for implementing for the HRM 4.0. So these are the literature reviews, introduction and literature review, and then research questions. How to measure the cultural readiness for HRM 4.0 for plastic SMEs, and what are the attributes that influence cultural readiness in HRM 4.0 for particularly for the plastic manufacturing SMEs, and how weaker attributes are addressed in this case of cultural readiness for HRM 4.0 in the case organization. So first the research question 1 and 2 is for the general irrespective of the any organization. Then research question 3 is focused on the, we took one case organization and we studied the current practice level and the readiness level. So relevance and significance. So here it is, we adopted here interpretative structural multi-grade fuzzy approach, followed by the importance and performance analysis approach for this assessment framework. So this is well-known assessment framework for the already existing others applied in manufacturing and service sectors. So we adopted this framework for this here in this HRM 4.0 readiness. So these are identified the enablers and criteria and attributes. So these all are the attributes. So these are the appropriate criteria for the attributes, and these are the enablers we identified. So from this attributes, criteria, and enablers, we are going for the develop the assessment framework using this multi-grade fuzzy approach. So plastic manufacturing organization, CASE organization is it's a very old organization, and they have more than 60 laborers, regular laborers, and also around 20 laborers in contract laborers available, 50 full-time on-roll employees and 10 variable employees, and then 25 contract laborers for based on these orders they are appointing. So this continuously it is a emerging sector. So the plastic manufacturing sector. So they want their production also, they are growing continuously. The orders are more. So they want to expand the company, and also they move to this HRM 4.0. They have the in the mind, although that's why they're projecting for this. Yes, the HRM 4.0 readiness towards they are moving. So the particular organization we took this case study. So this is a collected data for the attributes, and this is a weightage we got it for the irrespective of the industry. So, but it's based on the attributes weightage, criteria weightage, and then enabler weightage. This attributes weightage, criteria weightage, and enabler weightage, we got it. So this is, then we can perform this important performance analysis. So importance performance analysis based on the 4 quadrants we are splitting into those attributes. So quadrant 1 is for the performance is low, but the importance is very high. So there we need to focus more. So those attributes are weaker attributes. And quadrant 2 is it's already performance also good and importance also good. So these attributes will be preserved to continue in the same state. And the quadrant 3, possible to overkill. So here it is, the performance is very high, but the importance is very low, those attributes. So if we reduce the performance also, it's better. So that effort we can apply in the quadrant 1, those attributes, weaker attributes we can apply. Then the next 4th quarter, the low priority. So low priority, these attributes are importance also low and performance also low. So we are giving least importance for these factors. So for this IP analysis, we'll get clear picture for in this, which attributes we need to focus more, which attributes we need to give less attention. So how the efforts, manpower and efforts we can channelize from this one attribute where we give the importance, where we need to focus. So this will be getting this from the IP analysis, importance performance analysis, this importance performance analysis table. And suggested for the weaker attributes, we took the case organization. This case organization, we conducted this framework study. So these all are the weaker attributes. So corresponding the improvements we are suggesting based on the expert's opinion, we suggested the improvements. So practical implications. So this framework is ready to assess for their readiness level for HRM 4.0 implementation for managers and practitioners, and also the government organizations to assess any organization. So we can implement. So particularly here, the attributes are focusing more on plastic SMEs. So these attributes we can generalize possible. That's for the future direction. So generalize, then they can apply for any manufacturing SMEs, they can apply. So these are the conclusions. So the current case organization is 7 out of 10. So it's a very good readiness. So still the scope is there to improve their readiness level to reach to 9 or 10. So then they can go for the HRM 4.0 implementation. So future research direction, this is continuous assessment method. They can go for continuously every time interval after 3 months, or 6 months. Once the weaker attributes are addressed, then they can move to the next level. So next level. So highest level if they reach, then they go for the implementation in the particular
Hello,
organization. HRM 4.0
sir.
implementation. Yes, ma'am.
Sorry for the interruption. I think you're done with the presentation, right?
Yes, madam.
Yes. Now we can get to the question answers part.
Yeah, yes, sir. Yes, madam. Completed. Thank you, madam. Thank you, sir.
Thank you, sir.
So here, I don't have any question, but one suggestion for you that we can monitor the habits, working habits of the employee, right? And based on that, by like doing the behavior analysis of the employee, we can suggest the appropriate training to the employee. That is what we can integrate
Yes, sir.
over, and that
Yes,
should
sir.
be automated.
Yeah, yes, sir. So the weaker attributes we are finding, then we can suggesting. So based on the weaker attributes, we are providing appropriate trainings methods. We are providing, suggesting maybe training, maybe classroom training, or maybe job on-job training, or maybe online training, or maybe the seminars, or maybe management development programs or workshops. Some different kind of trainings we can appropriate trainings will be given to their employees, sir.
Thank you.
Thank you very much, sir. Thank you. Thank you.
Thank you, sir, for your presentation. Now we'll proceed to the last presentation of today's session. So now we'll resume the presentation which was going on previously by Tejas Vaj. Now, just give me a second, then I'll share on your behalf.
Hello. Hello.
Yes, please.
Hello. Yes.
Yes, ma'am. Can you share the PPT that I
Yes,
shared with you?
just give me a minute. Sir, I'll be sharing the screen, your PPT from the problem statement slide. Let me know when you want to change the slide. And please resume from where you left, since we have a
Yes,
time constraint.
yes, ma'am. I'll keep it short. First of all, sorry for the inconvenience.
Yes.
So I'll sum up quick. So problem statement. Yeah. So the traditional PC management and handling PC is difficult, especially if you give a Linux system to someone. So because it involves a lot of commands and you need to know a lot of things. So the thing is, how can we make it easy through AI? So ma'am, can you go to the implementation side directly?
Yes.
Next. Yep. Yep. This one. Can you play the video, ma'am? The implementation, the video.
Yes, sure.
Yep. Yep. So this is a demo of what we have done. So currently you see this is the interface that is running on the desktop, and I am prompting it install npm in my Ubuntu machine using npm. Okay, so I want to install Node Package Manager, which is a package that we use to develop website. And just by giving this command, install npm in my Ubuntu machine and then install Node version 22, it is running those commands that are necessary for it is installing all the packages it is running all the commands in our shell that are responsible for installing npm, and then it is installing Node with again running packages. And all of this it is doing it in the background. So it takes a bit time currently, and after a bit while, I will show you what are the steps involved. So currently, you see, it prompts like Node version 22.14 is successfully installed in the system, and you can verify that installation. So over here in the terminal, I'm just giving a command of Node version -c, and then we can see Node version 22.14 is installed in the system. So this is the power that we have we are showcasing. Ideally, you know that before we had ChatGPT, there were blogs through which we used to read these things and install on how to install a certain package or such a certain software in a system and install it. And after the coming of ChatGPT, what we do is we tell ChatGPT that these are the steps that please give me the steps that are involved in installing these things in my system. And after that, we copy those things from the ChatGPT, paste one by one the command in our terminal, and that's how we install it currently. But with this, even we eliminate the need of going to ChatGPT and getting the commands from there and running those commands in a system. Ma'am, I guess the video is frozen. Can you check? No. Yep. So this is just I just wanted to show like what are the commands involved in doing this, and these are all the things that a developer needs to do. Maybe someone who is new in this thing cannot like know, or if he or she gets an error while giving this command to the system, then again the thing is that you need to copy those error and paste it to the ChatGPT, and then that's how then you solve that error, and again then you proceed it. So it's a long way, and all of this is eliminated by this. Ma'am, can you go to the next slide? Sure. So can you play this one? From the next one, I guess. No, ma'am, can you play the second one video? Yeah. So in this one, it is an implement. In this one, we are focusing on use case where, let's say, you want to develop a website. So ideally, what you do is if you want to do it with AI, you go to ChatGPT and then you tell it like what a website you want, and then it gives you code. You copy the code and you paste it in a system in particular file. And with having this system on your desktop, you can just prompt it like this is what you have to do, and then it automatically generates the whole folder structure and on the whole website for you in your system wherever you specify that here I want to do. So this is one of the use cases. There are a lot, like you can summarize the documentation, documents. Let's say you have 100 words document in a folder. You cannot search each and everything, and if you want to search anything from those 100 documents, ideally you would open the document. But with this, you can just tell it that these are the documents. Can you please search where is this particular thing, and it will do it for you. So how does it works is basically that we with the same prompt, whatever prompt we give over here, we give it to the AI, and then from there it is generating the certain sequence of commands and sequence of tasks that needs to be done to execute that task. So it involves have some commands and it involves some scripts and running those scripts. So our application is having we have given the access to run some this command shell command, and that's how by running these shell commands one by one we can execute the task in our system. So like as you saw the node install thing and this documentation thing as well that is currently running in the video, users have to tell it that this is the project, can you document it, and it will generate a very good documentation for you, which you can add in the readme MD file. So these are the demo videos that we wanted to show like what exactly are the project is. So ma'am, can you go to the conclusion? Yep. So this that is all the thing that is over here are what we have developed. So the conclusion is that this solution is a unified solution and it is easy to use for people, and it is easy to use for someone who is new to the led to the world of technology. It enhances your productivity as you do not need to do some mundane tasks on your own. It is user friendly. It has a broad applicability, and you can apply. There are many use cases. Even there are a lot of use cases that we haven't explored because there are a lot of things that you can do using shell commands and running scripts on a system. And there is a lot of potential. Like if this is developed to a very good extent, then it can come to be a core feature of the OS as well in the future. So that's about our project. Any questions?
Which LLM you have used?
So currently we have used Grok, which is we are using Llama 3.1.
Sorry?
But we can switch Llama 3. Oh, Llama. We are using Llama 3.1 using Grok API. But we can switch as well. So we have a system that if you want it to be self-hosted. So you don't want your content to go on the internet. So you can have a self-hosted as well, Olama, and you can run it on a system. But it just the size of the project goes a lot more with that. That's the only thing. So just in case you want privacy with the software.
Okay, good.
Thank you, sir, for your presentation. Now we'll proceed to the closing remarks since all the presentations are done. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. On the behalf of the whole team, thank you for the support during the 9th version and all the previous 8 versions of the conference. We will be happy to see you in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. Lastly, I would like to thank our session chair, Professor Pat Shah, for chairing this session. A token of appreciation to the chair on the behalf of Team ICTIS 2025 and Global Knowledge Research Foundation and partners. Thank you, sir, for your valuable presence. Now, just before we end the session, I request all the participants to please turn on your cameras so that I can take a quick snapshot of today's conference.
Madam, certificate will be for all the authors. Certificate will be for all the authors.
Ma'am, no, I think it is only for the one who was presenting.
Okay, madam.
I would like to ask as well, for this conference, do we end here or is there any more session for tomorrow?
No, ma'am, there are no sessions for tomorrow. This is the one.
Okay, so it's just for today.
Yes.
Thank you.
Madam, please switch on. My camera is turned off from your side, please.
Yes, I'll switch on your camera. Okay. Just wait for a minute. Let everyone turn on their cameras, then I'll take the snapshot. I request other participants to please turn on your cameras. Okay, done. This was a great session. Thank you, everybody.
Thank you, madam. Thank you, professors. Thank you.
Thank you. Thank you, everyone.
Thank you.
Thank you.
I'm leaving. Thank you.